In this problem, we're given a number m and a set of n elements. And what we want to do is we want to split these n elements into m groups, such that each group is a size n over m, and each group has a different remainder. So one group is 0 mod m, the next is 1 mod m, all the way until m, m minus 1 mod m. So what does that really mean? So let's look at the answer for this very first test case. For now, we'll just leave the first line alone. So we're given these sets of numbers, and we know here m is 3. So our three groups would be 0 mod 3, 1 mod 3, and 2 mod 3. So now here we see the 3 and the 0 fit here, the 7 and the 10 fit here, and the 2 and the 14 fit here. So as you can see, they're all the same size, and that's what we want to do. Because if you look at it at the very start, it's initially a 6 and a 12, and we don't have the 7 or the 14, and the 6 and the 12, they both belong here. And so we just want to make sure that each of these groups are the same size, and the size is n over m. So what we can do is, let's have this vector called free, right? And in this vector, so we know the size, so n here is 6, m is 3. So the size of each group has to be 2. So if this size is more than 2, we can add the rest of the elements to this vector tree. So here we can add the 6 and the 12, and we can take it out from here. So now we look at 1. Okay, the size of this group is 1, and we want this to become 2. So we take the very last element that we have in free, and we put it here, and we change it such that it fits in this group. So currently 12 is 0 mod 3, and now we want it to be 1 mod 3. So we increase this by 1. So this becomes 13. And now we go here, and the same thing. So this is too small. We need to add one element. Is there one element? Yes, it's a 6. We want 6 to be 2 mod something. And the only thing we can do is we can increase this number by 1. So we can increase 6 by 1 to 7, but that's only 1 mod 3. So we increase it again to 8, and that's 2 mod 3. So this would be our final answer. And even though it's not the same as this, our answer would still work. And that would leave us with 3, 2, 0, our 6 became an 8, and a 12 became a 13. So we see there's a change of 2 here, and a change of 1 here. So the overall change would be 3. And that's the very first number. The first number is just the minimum number of moves to create equal groups. So there is one issue, such that, let's say, let's not care about this test case, but let's say we have a 3 here, this is 10, 13, and we have, this is too small, and all the numbers are here. So 2, 5, 8, 11. So now what? Because what we did is we would go from 0 all the way down till m minus 1, which in this case is 2. So what we do is we just go through this twice. And why is that? So here we can see, if we look at free is empty. And this is too small because the size should be 2. And then same here, free is empty, but this is too small. And all the elements we need to put in free are stored in 2 mod 3. So over here, once we take these 2 elements and we put them in our free vector, then on our second loop, we'll check here, is this too small? Is there something in free? Yes, we can now use this element here, and so on and so forth. So that's why we need to go through 2 loops for all the mods. And then the last constraint will be wanted with the minimum number of moves. And the only thing we can do is we can only add. So if, let's say, we don't care about the exact sizes right now. So let's say this needs something, and these 2 have too much. So this is too big and this is too big. Any of these two numbers, so any number we can take out and put into free can go here, but which is better? It's better to put a number that's closer to this mod, that's less than it, here. Why? Because we can increase by 1. To increase a number from 1 mod 3 to 2 mod 3 would just be plus 1. But from 0 mod 3 to 2 mod 3 would be plus 2. So that's why we always look at the back of this free vector. And I think that's all the logic we need to solve this problem. So first thing first, we get n, m, and the array. So n, m, and the array a. Okay, so now above, while we're solving this, we use some kind of mod groups. So what we can do is we can create a vector of pair long, which I will just call mod mx, and make a constant mxn of n goes up till 2e5, so 2e5 plus some leeway. So this is just an array of vectors. And why is it a pair of long, and not just some long? Because when we were dealing with putting them into its own groups of mods and so on and so forth, we didn't care about the index. But over here, we care about the change. From the 6 to a 7 is 1, a 12 to a 14 is 2, so it's 3. So what we can do is first, while saying the index at the same time, we can change all these numbers to fit the criteria over here, and then we can create a new list using the indices to the new numbers, and then we can just go through all the n elements and see how much all these elements have changed to keep track of the overall change. So that's why in this pair, the pair will consist of the number itself and the index that it belongs to. So then we can just say for mod of ai mod m, we will just push back the pair we want. So we want the element itself and its index. And yep, that looks good. So now we create this vector of pair long, which I will call free. And now we need to do this next process over 2 iterations just to take stuff from later mods back to groups of earlier mods. And now we go through all the mods and we just check. So if the mod is the right size, so if the number of elements in a certain mod group is exactly what we want, which is n over m, we do nothing. So we only care if mod I dot size is too big. So if this size is too big, we need to add all the elements until, so we take away elements until it is the right size. So free dot push back mod I dot back. We don't really care what element, so we can just take the element at the back, and then mod I dot pop back. And that deals with the case when there's too many elements, so we just add these elements to free. And then in the other case is when mod I dot size is less than n over m, and also free is not empty. Because if free is empty, we don't know what number to add, because the number we need to put in this group will come in a future mod. So we'll only see this in our second loop, not our first loop. So we don't do anything if that's the case. But if free is not empty, what we do is we look at the back of free and we get that number. So let's call it x, and that'll be free dot back. And then what we do is we just, of course, pop it from free, and then we move on. So we need to know what the current mod of this number is. So we just call this x mod, which is going to be x mod m. Oh, x dot first. Yeah, x dot first mod m. And then, because currently x mod is a pair, which is going to, sorry, x is a pair, which is going to be the number and the index. So we want the number mod mod. So we need to see how much we have to change this number. So if x mod is less than I, then mod I dot push back. So the index should always be the same, so it will always be x dot second, and then this will be x dot first plus I minus x mod. Yes, that makes sense. Otherwise, mod I dot push back x dot first plus I plus m minus x mod, and then the index again stays the same. Okay, so why do we do all this fancy stuff? So x first is our current number, and we can only increase the value of our number by 1, and that counts as one step. And so in this step, if x mod is less than I, then we know all we have to do to x mod is we have to increase x mod to a number that's I mod m, right? So we know that x mod is less than I, this number is positive, so we increase our number x. However, if x mod is bigger than I, then this number will become less than 0 and it will lower x dot first, but we can only increase x dot first by 1. So we need to increase everything by m, and then just the exact same thing, except we increase it by m, so the overall change was going to be bigger than 0. And so that's how we get this. So this handles all of the putting numbers in the right group, and then after all of this, we should have, everything should be in its right group. So over here we just have an answer vector in which we just go through for n for auto y in mod I. So now this y is going to be a pair of the number in the index, and so right now we care about the index. Will be y dot second, which is the index, equals y dot first. So in this index, we're going to save this number, which is exactly what we want. So now that we have this final vector, we need to calculate the offset, which is initially at 0. So then for n, the offset is going to be the difference between ans I and ai. And we know this is always going to be bigger than this because of all the changes we did here, and because we can only increase the number. So therefore answer I has to be bigger than or equivalent to ai. So there's that, and then we can just output the offset, and then for n we just see out answer I with a space in between everything, and that should work. This is LL, and then x dot first, oh, mod m. Okay. D 0 to 0, 13, 14, perfect, and no change here. That looks good. Submit. This should work. And voila.